Today on How It's Made. Escalators. Kevlar canoes. Goat cheese. And disc music boxes. Every day, millions of people around the world use escalators in places like shopping malls and airports. Escalators can move 100 or more people just as easily as one. Driven by a motor, these moving stairways make it very convenient for people to get around. Riding an escalator is easy, but building the smoothest and most quiet ride possible takes expertise. It starts with workers welding together the structural framework of the escalator. Like the chassis of a car, the track system and all other components will be bolted to this frame. A worker puts together the main drive gear, which hooks up to a motor with a chain. It will pull the steps and the handrails. He puts on an emergency brake device and uses bolts to secure it in place. He attaches side frames to the gear to make what is called the transition assembly. This assembly includes a drive gear for the handrail and allows the steps to loop back at both ends of the escalator. He then lowers the completed transition assembly into the truss, the hollow structure of the escalator. With the transition assembly in place, workers then install a cone plate, the last part of the escalator a person steps on before getting onto the moving steps. A worker makes the steps using aluminum ingots, which he puts into a crucible. They then apply a release agent to the mold used to make the steps. Spraying more lubricant on the mold ensures the aluminum stair will release properly from the die-cast machine, which automatically receives the exact amount of molten aluminum needed to make one step. A robot then takes the one-piece step from the die-cast machine and carries it to the trimming department. Here, a trim press removes some residual aluminum. The excess material goes back to the crucible to be recycled. Once the robot finishes a general trimming of the step, it sends it to the finishing department. There, finishing robots then file off the sharp edges. The robot also files in between the teeth that go across the step. Then it passes the step over a belt sander, making it smooth to the touch. Transformed from solid aluminum to a casting that is painted and assembled, the step is now ready to be installed. A worker rolls out a chain of rollers called a step chain. He greases all the pins. Then they place all the steps into position. Workers then connect the axles on the steps to the pins in the step chain, and then lock them together using a spring clip. They feed the required length of chain and steps into the unit. A worker then attaches a turnaround track. The turnaround track allows the length of steps to make a continuous loop from one end of the escalator to the other. The escalator runs for about 5 hours to ensure it operates quietly and properly. During this testing period, it goes through up to 250 quality control checks. After passing all the tests, workers wrap the unit in heat-shrink plastic. The escalator is now ready to load on a flatbed truck for delivery to the customer. Your canoe may well be made of the same material they use to make bulletproof vests. That's right, many canoes today are made of woven aramid fibers, better known by the trade name Kevlar. For canoes, though, they use a lesser density, since presumably no one will be shooting at you. A Kevlar canoe weighs about half as much as a wooden or aluminum canoe, and it's virtually maintenance-free. They build these canoes from several layers of Kevlar fabric, glued together to create a solid laminate material. It all begins with the fiberglass mold of the canoe's hull. The first step is to spread resin over its interior. Once that's done, they spread a sheet of Kevlar over the resin and rub it against the mold to push out any air bubbles. Then they trim off the excess fabric. Using a squeegee, they force out any excess resin and stretch the fabric until it's taut. This step ensures the laminate will turn out strong and smooth. They repeat this entire process with the second layer of Kevlar. Then run a roller over everything to expel any excess resin and press the layers tightly together. Now for some structural components. Pieces of thin, high-density foam go along the bottom of the hull. Glue bonds them to each other and to the bottom of the hull. Using a machine called a hot box, they begin heating strips of foam to curve them. These curved pieces are called ribs. They reinforce the sides, adhering with resin. With the structural core of the canoe complete, they now encase it in a third layer of Kevlar. Once that's down, they prepare to bond everything together with vacuum pressure. They lay down a sheet of white fabric impregnated with a non-stick coating to prevent the vacuum bag from sticking to the surface. This mesh, called scrim, goes on next. It helps stimulate airflow during that vacuum process. Now they tape a plastic vacuum bag around the mold, sealing everything inside. Then they connect one end of a hose to the bag and the other end to a vacuum machine. The vacuum steadily draws out the air from within the bag, pulling the layers of Kevlar tightly together. After 8 to 10 hours under vacuum, the bag comes off. If a canoe flips over, flotation tanks in the corners keep it afloat. Workers build each tank out of 2 pieces of low-density foam. After sanding them to the right shape, they lay a sheet of fiberglass mat over them and coat it with resin. This strengthens the foam and seals the 2 pieces into one unit. After the resin cures for an hour, they extract the canoe from the mold. The factory's quality control inspector checks it over, and if everything's okay, applies a protective coat of resin. Once that's dry, they cap the edges with aluminum strips called gunnels, which keep the hull from folding inward. Then an aluminum crossbeam and a nylon end cap on each end. A wooden yoke for carrying the canoe upside down on land, and a wooden seat with nylon webbing. Workers rivet all these components to the gunnels, then rivet the gunnels securely to the Kevlar laminate. This factory puts every canoe it produces on a digital scale to ensure it meets weight specifications. If all is well, the finishing touch is a decal displaying the manufacturer's name. Kevlar canoes, like those made of other materials, vary in size, shape, and design. A canoe intended for fishing or hunting, for example, is quite different than one designed for long expeditions, or for a two-person racing team, or for a solo canoeist. Goat cheese tastes harder than cheese made from cow's milk because goat's milk has a higher proportion of certain fatty acids which sharpen the flavor. There are hard and soft varieties of goat cheese. The soft ones are usually sold in logs or discs and often have a coating of peppercorns, chopped herbs, or other flavorings. The texture of soft goat cheese makes it ideal for spreading on crackers or crumbling over pasta or salads. Goat cheese is also called chèvre, the French word for goat. Farmers start breeding goats when the animals are a year old. The gestation period lasts 5 months, meaning milk production begins at the age of about a year and a half. The goats go for a milking every 12 hours or so. The first step is to manually squirt some milk into a cup to check the quality. If it looks good, they wipe the teats with disinfectant to remove surface bacteria. Then they hook up the automated milk extractor. A milking takes just 2 or 3 minutes. It typically yields 2 to 3 quarts. At the cheese factory, the goat's milk goes into a steam-heated pasteurization tank. An agitator stirs the milk non-stop to keep it from cooking. They heat the milk to 66 degrees Celsius, which kills off any bacteria. With the milk now pasteurized, they add bacterial cultures. These kickstart the fermentation. Then they add rennet. Diluted in water, rennet is an extract from calf stomachs. It contains enzymes which curdle milk. With the cultures and rennet in, workers now let the milk ferment for 18 hours. The result? Cheese curds in a watery liquid called whey. They ladle out the curds and put them in a cheesecloth bag to strain them. As they lift the bag, the sheer weight of the curds forces out much of the remaining whey. They tie up the bag and let the curds sit for another 18 hours, after which time workers strain them again. The goat cheese is finally ready. They weigh it and mix in just the right proportion of salt, 0.6%, to slow down the aging process. One of the formats this factory produces is 175-gram packages, so workers weigh out 175-gram blobs of cheese. Then, hand roll each blob into a ball. Then flatten each ball into a disc. The disc goes into refrigeration until packaging time. The fridge temperature is 3 degrees Celsius, just above freezing. Some goat cheeses go for a roll in special flavorings. These are chives. Then it's into cellophane wrap and a plastic container. On the product label, They stamp a best before date. Unopened, goat cheese has a 2-month shelf life. Once opened, about a week. Another format is log-shaped. They roll this particular variety in a 5-pepper seasoning. Workers also hand-roll goat cheese balls. They go into a container with spices, sun-dried tomatoes, and olive oil. Goat cheese is a healthy food. It has twice the protein of cow's milk cream cheese, yet half the fat and cholesterol, and 1/3 fewer calories. iPods may rule in this digital age, but there's nothing quite like a melody that's mechanically generated by a music box. It's why, more than a century after its heyday, the music box still holds a special appeal. Its musical chimes take us back to another time. A revolving disc, swirling dolls, and luxurious cabinetry. The music box is the original home entertainment system. Today, they make these authentic replicas with computerized tools. They contour gear for the spring-wound motor and then carve teeth into it. This gear is similar to the type used in clockworks. It's a wind-up device. Next, they coil a 20-foot-long strip of steel into a little cast-iron barrel. This is called a spring barrel, and it's the device that stores the wound-up mechanical energy. Once the clutch is installed, it will be ready to spring into action. This circular blade now sculpts the weights that extend from the base teeth of the musical comb. The weights are called leads, and they help produce the low notes. To tune the bass, a technician snips the ends of the leads. She plucks a tooth to produce a note, then measures its pitch with an electronic tuning machine. She adjusts it by clipping off a bit more. This process is critical. It ensures each of the 76 teeth on the musical comb will hit all the right notes. There's a damper for each tooth to quell its vibration. They install these dampers on a rail next to the star wheels, the part that plucks the teeth of the comb to produce notes. The technician aligns the dampers to the star wheels and bolts everything to a cast iron plate called the bed plate. Using a pincers-like tool, he checks the tension of the dampers and makes adjustments. Now he secures the upper comb to the bed plate and turns it around to install the lower comb. Music boxes with 2 combs instead of 1 have a richer sound. The technician makes more adjustments to the dampers to ensure a proper gap between them and the teeth of the musical comb. He installs the bar that holds down the music disc while it plays. Then he bolts the motor frame to the side of the cabinet, followed by the winding and disc drive gears. He attaches the spring barrel to the gears. Here, he installs a speed control mechanism for the winding gears. It's called the governor because it governs the speed. He winds the motor to power it up for a test run, and then checks all its parts to confirm the motor operates smoothly. When he's satisfied that it does, it's time to install the musical components, beginning with the soundboard, which amplifies the notes. Next, the bed plate with its double comb assembly is mounted onto the soundboard. He screws support brackets to the box. They'll prop up the musical disc. He checks the setup with the dummy disc. On a real disc, music is printed in the form of perforations. This master disc serves as a template to punch holes in a copper-plated disc below. The punctures form curls in the underside of the disc, and it's these metal curls that will set the music in motion. As the wind-up motor turns the disc, those curls snag the star wheels. The star wheels, in turn, pluck the teeth of the musical comb. The music isn't digital, but it's truly magical. The Music Box is one technology that stands the test of time. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/how it's made.